All right, from our speaker for tonight, we have Andreas Hölzlwimmer, who is actually one from Linz, so we didn't need to invite a speaker from Vienna today, although I found him in Vienna, but he can tell you that stories by himself. Please give a big round of applause to our speaker from tonight.
Turn the microphone on. Hello, my name is Andreas Hölzlwimmer. As has been said, I'm from Linz. What I'm going to tell you today is what is architectural snapshot testing. I'm going to show you the parts of the snapshot testing and what the combination of architectural and snapshot testing means. So, what is the content for today's talk? We have a short overview of the motivation why we at our company used architectural snapshot testing, a short poll who has used these technologies before, an overview of what is snapshot testing, what is architectural testing, what is architectural snapshot testing, each with their own demos, some real-life example outputs, a few takeaways, and if there is time, some questions. Okay, so what was our motivation? So first, I didn't have any other slide to put this in, so I'm working at Control in Linz, and I work on a project for Fonds Soziales Wien in Vienna. And what was our problem? We had a large and growing full-stack application. It had different developers changing architectural requirements, and that means you have old code bases, you have new code bases, you want to combine them somehow, and then you lose track of your architecture. It can happen, it shouldn't happen, but how can you avoid that? Especially if many teams contribute. So you have, like in our case, 8 teams that are working, and every team would be allowed to make changes in the code base. Of course, there are always pull requests, but you don't really want to look at every pull request in detail and tell them they did something wrong. It's better if you have tests that ensure that they know themselves that something went wrong if they broke something. Of course, that's the concept of testing. So, how do we ensure that people, either people within the team or people from outside the team, conform to your vision, your architecture? So you decide on a certain architecture. How do you ensure that? How do you sort of enshrine this architecture in a rule set that you can run every time you check in your code? And also what was important was to make those violations, if they happen, make them easily visible, that you have your screen in front of you and you see, okay, this here changed, and we could easily know how to fix it or what actually broke. So we have a short poll. So please bring out your smartphones. I hope you, all the way in the back you can actually scan this QR code. Tell me, have you ever worked with snapshot testing or architecture testing, or maybe both, or both together? And I'll give you some time because I'm really interested. I heard already that some work with snapshot testing, some work with architectural testing. I'm not sure if anyone worked with both or actually combined them. So I sort of intentionally didn't explain what they are, because if you have worked with them, you know what they are, and if you don't know, we will see later. I actually hope this is working.
Requires a login.
Yes.
Oh, I didn't set a login.
You have to choose a Konto Soziales.
Okay, sorry.
You can also raise hands. Should be easier. Yes.
One moment. Oh.
Anyone?
Does it work now? One moment, let me go back to this here again. Yeah. Now our first problem is out of the way. Hopefully the rest works properly. Ah, yeah. I mean, I did test it, but probably I was logged in with my account. But it's like, phew, at least it works now. A surprising amount who didn't work with either of them.
Developers, they don't need to test things.
I mean, of course, if you write perfect code, why would you need tests?
That's what the customers are for.
Oh, yeah. Customers test our architecture. So let's give it a little bit more time. Some people are still handling their phones. Okay. I mean, it's not like the ratio will change much more. So yeah, a lot of people have never really used either snapshot or architecture testing. A couple of use both, of course. So at least you can tell me if I said something wrong. Okay. 32 responses. Okay. Nobody's taking out their phone anymore. Let's continue. Thank you for your responses. Oh, next slide. Okay. So, what actually is snapshot testing? So we had 65, 69% or something that actually have never done it before. Maybe they don't even know what it is. Let's talk about it. So, what do you do when you do snapshot testing? You produce a state of your software that produces some kind of output. For example, you can do snapshot testing on a website. You create, you navigate to a certain URL. You can take a screenshot, or you can, just take the website HTML. You can use images and compare them. You can use any kind of output that you have. An output can be a serialized object in your code. You store that output, and then you compare it later to that output that you produced. You produce it, and like a week ago, you save it on Git. You make the output again. You compare these two, and you see if there are any changes. And if there are any changes, and you didn't actually intend to change anything in that location, you broke something that you shouldn't have, of course. A good thing about those snapshot testing things is that the mismatches are easily identifiable. I mean, it depends on the framework you're using. For example, if you use something where you can test your code changes, then of course you have diff tools that you can use where you have left side, right side changes. There are things that work for images as well. Of course, there are things that work for websites. And what you can actually also use is you have those mismatches are visualized in a local environment. So as I said before, you have a diff tool. You have, for websites, you have an HTML report you can view. Okay, so this is just an overview. So like you have two files. They have a content. You see that the third line differs. You have the left side is your expected, your verified. So you create something, you verify that it's correct, and it's now your master. And then you observe something, you observe that it's different. Here's the error. So there are two main ways to call these. The one is the approach itself is called the golden master approach or snapshot approach. So snapshot is the name, of course, for the approach itself, snapshot testing. But golden master is the way you create a master. This is your gold master that you have in Git, and you test against that. Mostly you compare objects or images. Objects, of course, code images that you can serialize. Images in case of websites where you take a screenshot of your browser. So you run the browser, you have 15, 20 screenshots so that you have you make a track of your flow in the program, and then that's something you can compare. Objects, of course, need to be serializable. In most cases, that's not really an issue. If they're not serializable, I don't know, make it so. It's something you just have to do. There are some problematic issues. For example, non-reproducible values. What are non-reproducible values? You start a program, you have a DTO, the DTO has a generated ID, a GUID. You have random values, you have an image with certain kind of noise in there. Or you have a DTO with a current timestamp. So those are issues where if you run the tests again and if you don't check that those kind of values are handled, every time you run those tests they would be different and they would fail. So of course any framework you use has to have some kind of way to avoid that. Another kind of difficulty can be that build pipelines don't really show those diffs very well, especially for images. How do you display in an Azure build pipeline that two images are not the same? Yeah, so that's good. You can easily view that locally, but sometimes it can be difficult to visualize that in a text-only pipeline. So what we are going to use today is Verify. We also use at FSW. We also use Playwright, but Playwright is more for UI testing, but it's also a snapshot testing tool. So Verify, you do code-based tests. So you compare the serialized objects. You have a text output, and you can use, as I said, your favorite diff tool to compare those two on your local developer machine. And for Playwright, it works by comparing, for example, it takes a screenshot of your application, you compare these two screenshots, and in the case of Playwright, it creates an image where every change between those two images is marked in red. So you see if there is a screenshot that's mostly white, but there are some red areas, that means, oh, it's different here, you did something wrong, or you can see, oh no, those changes were intentional. So both of these frameworks have ways around this issue of randomized values. For example, Playwright has the option that you can mask certain parts of a website that might be different. For example, you have a version of your program. The version would be different every time, and when you make a screenshot, you can't really easily change the version number that is in your screenshot. So you can say, okay, this part here, this is masked, and every time you make a screenshot, this would be black. So when you compare those two screenshots, the parts would be black, and you have no issues with your random values. Verify has a way as well, and I'm going to show you what that way is in the demo. That's part of one of the tests. Oh, of course, we're already at the demo. That was fast. So I'm gonna, if I'm finding this, okay, I'm gonna switch to duplicate. As I said before, it's easy to type blindly. It's not that easy to code blindly. So I have a short sample solution here. This is on GitHub. I have the link to the solution at the end of the slides, so you can check that out later. For now, we can ignore those projects here on top. They are more important for the architectural testing. This here, the verified tests, are the ones that are important right now. So what's in there? It's very easy. We have a DTO, we have an entity. The entity would be something that's, for example, in a database. The DTO is something you want to return to via your endpoint. And of course, you need a mapper between those two. I can show you here that the entity, for example, has last updater, which would be the person that last changed it. But for whatever reason, the developer decided this information is not necessary, so the DTO doesn't have that information. Okay, so we have our tests here, and my cheat sheet as well. So how would you write a verify test here? Let's do like a live example here.
Zoom in a little bit, please.
Zoom in a little bit. Ooh, better. And Copilot thought, I don't need to work. Easy for us. Okay, so what did we do here? We have our first entity, which in this case would be the entity we are mapping from. We have the entity we are mapping to. And then we use verifier, which is the code base from verify.net. And we tell it, OK, please verify those two entities. We run the test. And what's going to happen is that a diff tool will open up and tell us what the difference between the verified version and the received version is. Here we can see the verified is empty because it's a new test. There hasn't been nothing that has been verified before. And on the left side, we have the serialized version of our code, of our output, of our objects. As you can see, the last updater in the entity is here, but it's missing on the location DTO. And we have a small tooling here that just converts or transforms or copies the accepted files from the received into the verified here. And if I'm running this again, the test will be green, hopefully. Yeah, the test is green. And if you check here, this is our verified file. So this now is what we called earlier the golden master, or our snapshot. And every time something changes, for example, for some reason you want to postfix your name with something, you run your test again, and you have the change visible in your diff tool. So if this change was not intended, you easily see you made some mistake here. You can check where to fix it. Let's change it back again, or else the other files will not be correct. So undo. That was the initial test. So there are some other things. I have to zoom out a little bit. Oh, instead I'm going to just run all the tests and then show you the files that it generates. Okay, so this for example would be what happens if you don't handle the anonymization of your randomized values. So in this file you have two generated IDs, you have two now datetimes, and assuming I will accept this test, I'm going to show you the next step later, then this would mean the next test would fail in this case. This one here would be, you can do different settings. I mean, you didn't really see the other one. For example, here you see this is not JSON format because the names on the left side are not made with quotation marks. And you can change this so you have quotation marks that you can use your normal Visual Studio Code or something, and it easily has a JSON markdown handling. And you can see this nicely colorful way of handling your data. And yeah, it's easier to see if you have more color in there. So yeah, this here would be that you can name the objects that are the results that you have, so you can give them meaningful names. And if you want to see how that works, so here we have the settings, so it's just a settings object. You tell them, please use JSON here. Here you have something that says, okay, please don't scrub. Scrub meaning they remove the datetimes or the GUIDs. And the last one here would be the named objects. So it just uses those this anonymous object and uses the values or the names of these properties that you created. Let's accept them. And if you run them again, you will see all of the tests green and one of them red. And the red one, as I said before, would be the one with the missing datetime and GUID scrubbing. Come on, come on, come on. Should it? Oh, I think I didn't run all the tests. I just ran the one test. Okay. So as you can see here, you have a newly generated ID, a newly generated time, and this doesn't work. Just to show you the difference here, if scrubbing has been done, instead of a datetime value, you see datetime 1. So it goes over all the datetime values you have and replaces it with a string. And for example, if you have the same datetime in multiple locations, it replaces it with the same value. Okay, as that's for snapshot testing. So it's good for mapping stuff, and you can see, one moment, let's switch back to the slides. Okay. This is especially useful if you have mappings or you don't really want to assert every kind of detail. You just want to have the entirety here. You can verify it visually, and then when something changes, you see it, and you don't have to change your assertions. Yeah. Next topic, what is architectural testing? So we have snapshot testing done. What is architectural testing? One moment, I need my cheat sheet here. So it allows you to extract attributes from your architecture. For example, what are the dependencies? What are your hierarchies for your types? What are the namespaces? You define your architecture by telling it which assemblies are actually part of your architecture. You define the layers. For example, you have a host layer. The host layer has this and this and this assembly, but only if this namespace is in that file. You define your rules. For example, that something can only depend on something else. And then you run tests which say, okay, use this rule on this layer, use this rule on this layer, and you mix and match your tests, your rules for your tests. Yeah. Here we have, one moment. Oop. This is from the documentation for ArchUnitNet. I just copied out a few examples. So for example, here you have the architecture would be you load 2 assemblies and the entire architecture is in either of these 2 assemblies. For layers, you say, okay, we want all types that reside in an assembly with a certain name, and you give it a human readable name. You have all the classes that implement a certain interface, and that's how you define your layers in this case. And this would be an example for the rules. So you have an architectural rule that says classes that are example classes should be in example layer. So when you later say, okay, I want to check this layer against, or this rule against the architecture, if there is a file that shouldn't be there, if it's not named correctly or whatever the rule is that you set up, yeah, it will fail and it will tell you what you broke. Okay, what's the benefit of architectural testing? It ensures that, so you have a developer and he makes changes because he thinks, what could go wrong? And then he didn't really know. For example, he's not from your team. He didn't know about your discussions about architecture, what your vision about your architecture is. You're made aware that you broke the rules of your architecture. You skipped a layering, for example, so you went from host directly to the database. Yeah, stuff you shouldn't do. And instead of just having to go through every pull request and marking everything that they did wrong, it's way easier to just, see at the tests that are run locally or in the pipeline, you did something wrong before you even made the pull request. Fix it before you tell us. And of course, sometimes those changes are intentional. So every time those tests break, every time you have a difference in those 2 files, you can ensure that those changes are made intentionally. You change the tests because you know that architectural style has changed for some reason, or the files there was not necessarily architectural style, but you made a conscious exception for certain rules, for example. Of course, it's most effective if you start up a project because you don't really have to change anything if it doesn't, it doesn't break your architecture. You just have to make sure that once you make those rules, that every new thing you make adheres to those rules. But it can be a little bit more difficult if you start it later in the project. Not impossible, just a little bit more difficult. We also did it late in our project. Yeah, those exceptions can also be a good place to put your technical debt backlog directly in the code. So every time you break a rule and you don't really want to change it because you don't have the time right now, happens. Sometimes you have a schedule you have to keep. Then there is a place where you can put your exceptions without actually having to refactor the entire code base. And last time I checked, it had issues with generics, so you have to make some special handling for generic types. This is especially important if you, for example, have dependency injection where you tell the dependency injection add every type with that generic. You might have to do some magic with ArchUnit to fix that. So, as said before, that the other projects are not that important, now they become important. So this would be a visualization of the project in the sample solution. You have a host layer. The host layer doesn't know about the application, it only knows about the contract. The application has services. The service in the application knows about the domain, it knows about the repository contract, but the application shouldn't know about the repository, the implemented repository itself. So you have a separation. You only know the interface of the stuff you want to call. So you might disagree with that approach. We just want to show this is a sample, this is how we test it. There are two main issues that I set up here. One of them is our target architecture is that we don't really want to access the domain from host. We just want to know what the DTOs are, but that's not implemented yet in that solution. So, for example, if for whatever reason you just want to, your endpoints only should return DTOs, you want to do that mapping in application, and host only gets the DTO objects. So this here would be a violation that we actually know domain. And the other one that's breaking is in our city service, we have a direct reference to city repository. I will show you later, instead of using the city repository interface. And we will see how we can test this. How to actually test it is part of the architectural snapshot testing part, but I just wanted to show you this is the architecture, this is how it looks right now. So the name already appeared before. What framework are we using for architectural testing? It would be ArchUnit. ArchUnit is, at least ArchUnit.net is a .NET fork of a Java library. You can check it out later. It has quite a few examples. And now we have another short demo about just ArchUnit. Let's go for, duplicate again. No, my cheat sheets. We are already done with verify. Let's check our ArchUnit. Okay, so what's in this code? First, I'm going to show you for one of the examples here in application. For example, we have a weather service. The weather service uses the iWeather repository. The repository is in the infrastructure project. But if you check the city service, it uses the implemented class. So this is the way here we have an issue. This shouldn't be happening. It happened somehow. Okay, we have to make a test that ensures that it's working. But first things first, we have a few basic tests that just use ArchUnit. For example, are our controllers named correctly, or are they in the correct layer? So we have here the example. We load our architecture. This architecture includes all the assemblies. We define our host layer. It means host layer are all the types that are in the namespace that match host. You can also say it is in this assembly, it is in this namespace, it has all kinds of rules that you can think of. And then we check all the controller classes and say, okay, classes that have names ending with controller, those are our controller classes. And then in Fluent, well, everything here is Fluent, but you say, okay, the classes that are controller classes should be in the host layer. So if we run this currently, this is working because I didn't intentionally break this yet. And also I didn't hope that I didn't unintentionally break it. Everything happens. Okay. So this means, for example, what can we do to break this to check if it's actually working properly? We go here and we add a test controller. Let's just to make sure, make it public. We run this test again, and now it should fail. Yes. I love it when a plan comes together. So classes that are controller class. Of course, one moment. This is a bit longer. Should be in host layer. And then it lists the violations that you had. And of course, if you remove the test controller again, the test would be working again. Since I don't really want to... One moment. Oh, come on. You can copy paste here. Then we have another notepad. One moment, please. I wanted to implement it, but I think it's better to just... it's here. Just copy paste it to save a little bit of time. I think I'm not... Okay. So, for example, we said before that we want our... sorry, no, not here. We want our interfaces to be... we want to have interfaces to instead of our direct references to services. And... I broke something here. Okay. We want we have contracts projects, and they include interfaces. And for some reason, we say, okay, our interfaces should only be in contract projects. So we have our types here that say, okay, if they reside we have types that reside in those two namespaces, and they are our contracts. And we have interfaces, so it looks over all the assemblies and says, give me all the classes that start with I. Those would be our interfaces. There are also ways to make a rule that say, give me all interfaces itself. It's just, just a sample that I did here. So there are ways to use it without them actually having to start with an I. And then you say, okay, types that are interfaces should be in contracts. And again, you run this test. Up, out of the way. I'm so used to a mouse that using a touchpad is also always a little bit of a challenge. Yeah, it works now. And for example, we want to test it again. Domain is obviously the perfect place for an interface. Oh. You run this test again, and the test will fail because you have an interface outside of the contract projects. I mean, it's always nice if a test is green, but if you can't make sure that the test breaks if it should, it's not really worth that much. Okay, so there is also I tried to start a way to check for dependency injection, but I ran into the issue of generics, and I didn't really want to invest the time to make generics work with that code base. Yeah. Okay. This so much for the demo for Arch Unit alone, standalone. And let's continue. Up. This was unintentional. One moment. This one is correct, I'm sorry. Okay. So, now what is architectural snapshot testing? You combine those two approaches. You have your snapshot test, you have your architectural test. How do you combine them? You define your rules, you extract namespaces, you define the layers that you want to test, you have a structured output where you can put your namespaces, because the namespaces are what matter. You don't really want to use a class by class basis, because then your output files would explode. And you put any kind of output in there that ensures that when you break the test, then you easily see what you, where the violation was. So what are you doing when you do architectural snapshot testing? You create a text-based visualization of your architecture. This is the output file. It can also have an additional benefit of working as a documentation. I mean, it doesn't really make a nice graph that obsolete. A nice graph is always good, you know, a flowchart or something like that. But if a new developer joins your project and he asks what's up with that architecture, here's our visualized, or at least textually visualized, architecture documentation. It synergizes as well with some tool support. For example, there is the option that you go over your entire project and say adjust all namespaces, so that every namespace you have matches the location where it's at. So, for example, if you move the file but you didn't change the namespace, then the test wouldn't fail, because, for example, if you work only with namespaces in your architecture files, you didn't see that, but every time you check in and you do adjust namespaces first, then you're assured that your test would fail if you did something wrong or you missed something. I will show you later that how it can be used to document technical debt. And of course, you can cover both layering and slicing. Layering would be host, infrastructure, domain. And slicing would be you have one module, you have another module, you have a third module, and how they interact with each other, where they may interact, which layer can access which other layer. For example, you can have your normal domain language and you have your core that has core functionality, and at what interface location can you use to access the one from the other. And because we didn't have Visual Studio open for that long, I'm going to show you another demo. And I'm going to find my mouse again. Here it is. Okay. And I'm going to find Visual Studio. Yes. Okay. So before I already told you this is our architecture, and I have. It's not really that important what those files here are. If you want to check the sample solutions yourself, those are supportive supplemental classes that help you define your tests. What is important in this case is our architecture test class. And here, for example, you have the definition of your layers. The definition of your layers is first you set up all the assemblies, you build your architecture, you define your layers. For example, the host layer is every type that exists within the assembly of our host. Of course, you use a normal type of here. This would also be possible to just use the name as a string. Yeah. So you define all your layers here, and then you can reference those layers later. So how do we set this up? So I mostly used, with permission, the code base we had for our snapshot testing, architecture snapshot testing. So, yeah, it's extensive if you check it, but it's quite helpful. You have your architecture here, which is all the assemblies together that is created when you do setup architecture. This is the layer under test. You means what references can your application layer have? And this here means, this object here means, okay, the application layer may reference domain layer, and it may reference the application contracts layer. And also, there are certain namespaces outside of your layering that are allowed as well. For example, Microsoft SDKs, system, anything you might use, a third-party library that you use. So you can reference those namespaces and say, okay, we know those are not within our architecture, but they're allowed. We can reference them. You can work, of course, with namespaces. This is important as well. And here we have, one moment, it's uncommented now, but for visualization, I'm going to comment this out. Here would be exceptions that need refactoring. And if I am running this test right now, you will see the output file. So as before, we create our tests first. We want to create a golden master. So we have our received and our verified is empty. So what do we have here? The namespaces inside our layers application. If there are more namespaces or more assemblies that are part of that, then you would have more lines here. And as we can see here, the allowed namespaces here would be application contracts and domain. Also, as we said above, if there are more namespaces within those layers, it's just a sample project, it just has one namespace per, per project, then of course there would be multiple lines. I'm going to show you some real-life examples later where you can see that happening. We have our allowed namespaces not in layers. This would be the system namespace. And now here we see, oh, we have some namespaces that have not been accounted for. They are not anywhere in our layering. So before I want to fix it, so for example, I go here and say, I am going to accept this, and I'm running this test again. You would think now we have accepted this, we run it again, the result is the same, but you see that the diff tool doesn't open up because it's not a verify issue, it's an issue of our architecture. And the error is there are unaccounted for namespaces, which means we have our result, and after we ran the verify part, we check that the unaccounted for namespaces have to be empty. Every namespace you have in your architecture needs to be accounted for. Either it's a namespace inside your layer, it's a namespace of a depending layer, it's some third-party namespace, or it's a violation that you have to check up later. Nothing can be unaccounted for. How do we account for them? Here, for example, is the reasoning our infrastructure is accessed directly. Application layer should not depend on infrastructure layer directly. This is an exception. And also, we somehow missed before, I don't know why, we missed that there is a third contract or second contracts layer that we can access here as well. We run this test again. Now, of course, we will see the diff tool again. And now we know on the left side, this is our new received file. We have no unaccounted for namespaces. And we have the namespace and reason for our violation here. One moment, my mouse. Okay. So application layer should not depend on infrastructure, use contracts and dependency injection. Okay. And now if we accept this and run this again, it finally turns green. Okay, so here you see, okay, this is a sort of a refactoring backlog. And if you check all over your files and you see, hey, there is a violation, you need to fix it somehow. It doesn't really mean you have to fix them immediately. That's why you will have exceptions in your code base. In our case, we reference user story numbers from Azure there so that we can easily go to Azure and check, hey, we have a backlog. This is the user story number, please. When you fix it, this is the way to do it. Another example would be, for example, host. As you've seen before, we had 2 red arrows in our architecture, 2 mistakes that we made. And the second one would be that the host is actually referencing the domain. And for our purposes, that is not something we want. So we run this test again. We have our external namespaces. Host, of course, has access to ASP.NET Core. And here we also have the unaccounted for namespace domain because in our architecture it's not intended. So in this case, we also have to, say this is a violation that needs refactoring. We run it again. Unaccounted for namespaces is now empty. We accept this new golden master. We run them again, and then the test would be green. I'm going to run this first, and then I'm going to show you the result file. So the result file would be here. So while domain technically is part of your application, part of your architecture, but not the correct layer, it wouldn't be here in the allowed namespaces of depending layers. But of course, it's in violating namespaces. Okay. So that's more or less the basics. There are other tests you can do. I can show you some output files of other tests you can do. But this is the general idea how you combine those two. So you have an output file, you have a golden master, and when you change something and it's not intended, your test breaks, of course. So now I'm thinking, okay, what are some real-life examples? I'm gonna show you this here. Those are, of course, I couldn't really use them one-to-one because I had to anonymize them a little bit. This would be an example of we have one of the slices has an infrastructure layer, and here would be the output file, what it would reference. We are allowed to reference our temporal table core functionality. We have multiple namespaces within the slice, and we are allowed to access our internal core slice. This is the namespaces of our internal core slice. Here we have an example for our host layer. Our host is responsible for publishing our message bus integration events. So there were before I anonymized it and truncated it a little bit, there were 50 namespaces here because every kind of event has their own entry here. And those are allowed because our host uses Hangfire. Hangfire, as a job scheduling, sends those integration events to our message bus. The message bus is company-wide, so yeah, we have a certain structure we have to adhere to. In our core, we may reference other core domain. So the core module host may reference core domain. It has certain allowed namespaces that are not in that layer. So those are external libraries. Hangfire, I said already, for job scheduling. Mediator for handling communication between layers. Yeah. And here, this was a rather old part of our code base, so there's a lot of technical debt. And we just didn't have the time to fix all of them, but we have all of them listed here. As you can see, we have references for our task numbers in Asia, and also in our personal tests, if such a violation happens, but the underlying namespace is no longer exist in your architecture, it also fails. Which means once you fix the issue and the namespace no longer shows up, it breaks and it tells you, hey, you have something that's that's listed in the correct layer, but it's also listed in the violations. Something is wrong, please fix it. You can remove it from the violations. But that was a little bit of a recent change, so it's not in that sample project yet. Okay, and one other thing, it would be, for example, that you list all the namespaces of your layer. For example, you have a host layer, and what namespaces are in that host layer, what namespaces are in the references. For example, the infrastructure persistence, what does it include? DB context, auditing, our search, what are the contract projects? And so, for example, if you change your slice itself, usually two things change. One of those module test changes, so because you have a new namespace here, and also here you might have a change that says your fundamental code base changed as well. Okay. Almost at the end, we have a few key takeaways. So again, as I said before, I think 2 or 3 times already, I'm not sure. Ensure that your architectural changes are always intentional. So it's not bad to change your architecture necessarily. It's just bad to change it and not realize that you have changed it. That's the main purpose of that. You can display your changes easily, and you don't have to sift through 50 asserts in your architectural test just to find out where or what actually broke. And use your tests as a documentation. The test results can be used as a to-do list. As I said, there is the violations, and this is a sort of a to-do for your technical backlog, for your technical debt. And of course, it can support you in making targeted changes. So only this part of the code should change. And if you change one thing and you broke a test in another slice, yeah, you fucked up. Yeah. Yes. It can also show unexpected dependencies. One part of them already said, you change one part here and another slice suddenly breaks. Or that there are transitive changes, transitive packages that come in. This would be a good way to check for those recent supply chain attacks. For example, you run something and suddenly you have a new dependency that you didn't have before, just because you updated the NuGet package. Hey, easy gateway for checking that. But of course, there's a downside. It can require a higher initial investment because you have to set up your infrastructure, your architectural tests. Okay. I hope I wasn't too fast. Any questions?
I think in your examples you had a class named architecture verify. How much complexity is hidden away in this class?
Okay, how much complexity is hidden in the architecture file? So all the files that are here in the core folder, I suppose. That's the general question. How much?
In the architecture verify.
Yeah, so all those 4 classes are necessary for the entirety of the tests. And of course, here is the logic, and the other one are mostly just, interfaces and classes. So it can be quite a bit. So there is quite a bit of complexity. For example, you have a violation. You have those rules, and one moment you saw before that you have the unaccounted for namespaces. This is the assertion that handles this, for example. So also you have to actually load your architecture. You ensure that you can extract your namespaces. So of course this is front-loaded effort that you have to put in to create those tests. But once it runs, it's those core files we don't really have to touch a lot. Yeah, we set it up that it's really adaptable. And for example, if we add a new layer, a new architectural layer, or a slice rather, a new module, it's one new class that implements an interface, and you add that one class to a list of all your modules that you want to test. And the remaining stuff you have to do is create your verified files. So it's really adaptable if you if you set it up properly, I suppose. Does it answer your question? Yeah. Any more questions?
If you plan to do like a major refactoring of your architecture, is it like how would you handle this? Would you then adapt the tests immediately, or would you just add a few exceptions until the developer of the test framework was able to handle all of the changes which were made?
Difficult question. So the question was, for the microphone, sorry. How do you handle major refactorings? When do you change the architectural tests, and when do you change your framework, or do you change them at the same time? How do you handle that? Depends on your testing approach. So some people like the test-driven development, so they change the architecture test first and work on it until they are green. Sometimes I don't think about that. I change something and then I fix the tests. So it's it's really hard to say. So it really depends on. It's more or less a team or company philosophy sometimes, because some companies want to say, please do test-driven development or prioritize test-driven development. It's really up to you. So I can't really give you an explicit answer. It's even within our company, it's sometimes this way, sometimes the other way.
If you have a known violation of your architecture, can this approach prevent developers from adding more violations?
So can the approach avoid more violations if you already have them as a violation set up? It depends. So if this second violation fits the same rule set as the first violation and no namespace changes were made, for some reason, like you have the same namespace but a different class and it only checks for namespaces, of course you wouldn't really see that easily. So if you have it on a class base but not on a namespace base, it would be easier to check that, but then your architecture verified files would explode in size. But if you, like, for example, do that same mistake in a different namespace, it would pop up immediately again. So it depends on what kind of violation you repeat.
Okay, yes, I have something in mind where, depending on your example, it would be the host layer access the data access layer directly, and this is old code, and now we have a business logic layer between those two.
Mm-hmm.
And I want to change the code over time that points where the host layer access the data access layer directly gets fewer and fewer, not more.
Yeah, we didn't really cover that in our test code, so I can't really tell you, okay, this is how you fix those kinds of situations, but there are ways. You just have to be creative with your, the architecture verify file in this case, Sorry, I can't give you a better answer there. So there are situations where it works, situations where it doesn't work. Or in our implementation, it doesn't work yet. Okay.
All right. If there are no more questions, thank you very much for combining my two favorite testing methodologies together. Thank you very much, Andreas. We got you a small little speaker present as usual. Please, again, give a big round of applause to our speaker from the mic.